In this video, I'll be covering how to do linear regression on Jamovi. So, linear regression is basically a statistical method used to model the relationship between the dependent variable and one or more independent variables by fitting a linear equation to the observed data. So here I've used the states data set. My dependent variable is extraversion, and my covariates are retweet, entrepreneur, privacy, mortgage, scrapbook, and modern dance. Essentially, I'm trying to find a relationship between the dependent variable and these variables, and also establish a regression line for the same. So before we start, we must look at the assumption checks for autocorrelation, collinearity, and normality. So for autocorrelation, we're using the Durbin-Watson test. So here the DW statistic ranges from 0 to 4. A value of 2 indicates that there is no autocorrelation. A value close to 0 indicates positive autocorrelation, and a value close to 4 indicates negative autocorrelation. So here the value of the DW statistic is slightly higher than 2.75, which indicates that the value is closer to 2, which and it's closer to 4 as well. It's between 2 and 4. That indicates a slight negative autocorrelation, which is fine. Now, collinearity. For that, we look at the tolerance. The tolerance is supposed to range from 0 to 1. The value of 1 indicates that the predictor variable is not collinear with any of the other predictor variables. And the value of 0 indicates that the predictor variable is perfectly collinear with one or more of the other predictor variables. So here, most of the values are close to 1, and we can round off most of the values to 1. 0.7 can be rounded off to 1, 0.8 can be rounded off to 1, and we can say that most of the predictor variables are not collinear with other predictor variables to a large extent, except for mortgage, which is leaning towards 0, saying that it is collinear with the other variables. So, and that is also okay. And now we look for normality. Here, we're just checking if the data is normal or not using the Shapiro-Wilk test. And here the p-value is greater than 0.05. Hence, the data is quite normal. Now, how to create the equation. So here, y is your dependent variable. Your dependent variable is extraversion. And click on is equal to, and start with the intercept. The intercept here is 48.74. And now we look at the p-values for each of the covariates. So for retweet, the p-value is 0.011, which is less than 0.05, indicating that there is a relationship. Yes, there is a relationship between retweet and extraversion, and we're accepting the alternative hypotheses. And the same process goes to entrepreneur and privacy. But now look at mortgage. Mortgage is greater than 0.05, which accepts the null hypothesis and rejects the alternative hypotheses, and indicates that there is no relationship between mortgage and extraversion. And for scrapbook and modern dance, the value of p is less than 0.05, which indicates that there is a relationship and the alternative hypothesis is true. So we do not include mortgage in the equation that we're making right now. So here we put in y is equal to 48.74 plus, now take retweet, and its coefficient is 3.97 into retweet, plus the coefficient for entrepreneur is 4.11. And here we can say entrepreneur. Okay, and over here, privacy, the coefficient here is negative, so we use a minus sign, minus 0.65252 into privacy. Mortgage is excluded. For scrapbook, it's again positive 3.33 into, sorry. And then for modern dance, it's negative, so minus 4.59 into modern dance. So this is the equation. Now, if you want to look at the model, but only for one variable or two variables, you can scroll down to model builder, add a new block. Let's just say you only want the relationship between extroversion and retweet. Sorry, retweet. Let me try the variable. Retweet. Okay. This is the second model as well as the first model. Okay, the second model includes all of them. Let me delete block one. Okay, so here I have privacy and mortgage for block one. So you can look at the block with only privacy and mortgage. And if I add a new block, I can look at it for only scrapbook and modern dance. And I can select which block I'm looking at. Model 1 will only show me privacy and mortgage, while model 2 would show me privacy, mortgage, scrapbook, and modern dance as well. And I can create my equation according to that. Okay, now what are model fit measures? So over here, we've measured the fit of the model using R squared, AIC, BIC, and RMSE. Uh, AIC stands for the archaic information criterion, BIC Bayesian information criterion, and RMC root mean squared error. These are essentially just the measures of differences between the predicted values by a model and the observed values. It's frequently used to measure the goodness of fit of the model. And over here, we mostly rely on R squared to tell us the accuracy of the model. So here, according to R squared, the second model has 26.90% accuracy, while the first model is not that accurate because the accuracy is only 0.08.56%. The explanation for that would be because of we can look at our assumption checks. The tolerance level is, although it's close to one, it's kind of midway for privacy and mortgage. That's why the model is not fit. The closer it is to one, the more fit your model will become. Thank you.